Hello engineers, it's Mr. Heller here with another video, the first one in a series of videos about rotations. Now we're obviously all very aware of things which turn, things which rotate, whether that's modes of transport and wheels that rotate, engineering devices such as drills and drill bits that might be rotating, energy production, turbines, so on, energy storage like flywheels. So there's a lot of contexts that we can look at for rotations. To start off with this week, we're simply going to be looking at some of the ways we can talk about the speed with which things are rotating. Okay, so that might be things like revolutions per minute. We might be talking about revolutions per second. But actually the unit that's going to be most useful when we come to substitute into later formulas is an idea of radians per second. And that's our angular velocity, omega. A Greek letter, omega, looks a little bit like a W. Radians per second, angular velocity. So whenever we need to substitute a value for omega, angular velocity, we need to make sure that it's radians per second that we're using. Okay, so we met the idea of a radian when we were looking at idea of turn, ideas of angle. And a radian is just less than 60 degrees. And it's the amount of turn, 1 radian, such that this distance here, r, is the same as that distance there, r. And that's 1 radian. So it's really linked to the idea of a radius. So the part of a turn, so the radius is the same amount of a turn there. Whatever r is, then this distance here is going to be r if that's 1 radian in there. Okay, so really important measure for all sorts of mathematical reasons as well. So let's have a look at this fidget spinner. The fidget spinner turns 80 times in 5 seconds and the radius is 4 centimeters from middle to edge. So the first question is, how many turns per second? Well, if it's 80 revolutions in 5 seconds, I can simply divide both sides of this by 5 and work out that that's 16 revolutions in 1 second. So I've answered the question, how many turns in 1 second? 16 revolutions per second. Nothing really needed here about radians. So when we come on to answer the question about what's the angular velocity of the fidget spinner, now I need to change this revolutions per second into radians per second. That's where I need to remember that pi is going to come in. I'm going to times it by 2 times pi. Okay, so the angular velocity of the fidget spinner, 16 revolutions per second, times it by 2 pi, comes out at just over 100. In fact, if I round that off correctly, 101 radians per second. Okay, and then the velocity of a point on the edge of the fidget spinner. Well, you might say, well, why is it important that I'm talking about the edge of the fidget spinner? Well, as this turns around once, this point on the edge, it's obviously got a lot further to go. It's making a bigger circle than this point in the middle. So even if it's traveling at the same speed, and they are traveling at the same angular velocity, this point at the edge is going to travel a lot further than this point closer to the middle. And I can use this formula, not on the formula sheet, one that's well worth knowing. The velocity in terms of meters per second is omega angular velocity times the radius, the distance from the center to the point we're talking about. So substituting in 101, in fact I'm rounding that off to 101, the radius 0.04, because this is meters. If I'd use the unrounded version, it's going to come out as 4.02 meters per second. So if this is spinning at full speed, then a point on the edge is going to travel about 4 meters in 1 second. Okay, second question, a drill bit's turning at 1600 RPM. That's going to stand for revolutions per minute. The radius of the drill bit is 3 millimeters. So straight away, I'm going to convert that into meters because it'll make it easier later on. Okay, how many turns in 1 second? Well, if it's 1600 revolutions in a minute, divide that number by 60. It's going to come out at just under 26.6 recurring revolutions in 1 second. Going from minutes to seconds, fairly obvious, dividing by 60. Okay, and then the angular velocity, remember, times in by 2 pi to get from turns to radians, 167.57 radians per second. Angular velocity, it's implied that the units need to be in radians per second. Then the velocity on the point on the edge of the drill bit, again, I'm going to use this really important formula. Velocity is the angular velocity times the radius. angular velocity times the radius in meters is going to come out as this number of meters per second. So just to recap, we need to be able to convert between revolutions per minute or revolutions in a given amount of time, whether that's minute, minute and a half, a number of seconds and so on, to revolutions per second, and then from revolutions per second to radians per second, times by 2 pi, because it's this angular velocity here that we're going to be substituting into a lot of our formulas. Okay, so hopefully nothing too tricky there. Don't forget to email me if you need some help, but this idea of converting revolutions per minute to radians per second is going to be absolutely crucial as we go forward over the next few weeks and look at things like energy and momentum and power of things that are turning. Okay, so good luck with that. Don't forget to email me if you need any help.